In this video, we're going to go over the Riparian Function Assessment tool. Using the RAPs that we generated previously, we'll determine design types for buffer zones. This will be done conducting a cross-classification of two variables, the runoff delivery, which was calculated when the RAPs were generated, and then the denitrification potential, and that will involve looking at the height above channel grid and therefore the water table height. Alright, so we're in our map document. You can see I've made my riparian analysis polygons transparent. We'll come over to the Riparian Assessment toolset and open up Riparian Function Assessment. We have two inputs here, the riparian analysis polygons, and then our second input is our height above channel roster. We'll get one output, and that's going to be a table, a riparian function table. So let's grab our RAPs, put them in. Our height above channel is automatically added, and this is automatically populated. It's called riparian function. So we'll hit OK. We'll let it do its work. So the first step of this tool is to determine the local runoff to those riparian analysis polygons. In the second step, it identifies a shallow water table, which it does by using the height above channel roster and finding the zones that were less than 1.5 meters above the channel. Next, the riparian analysis polygons are overlaid, and within a RAP we determine how much runoff is going to it and what's the average width of the shallow water table within there. Next, we need to assign a denitrification rank and a runoff rank before we can begin our cross-classification assessment. So for the denitrification rank, we look at the low-lying land's average width within the RAP. If that average width is greater than 50 meters, we assign a rank of high. If it's between 25 and 50 meters from the stream, we assign a rank of medium. And if it's less than 25 meters from the stream, we assign a rank of low. Next, the runoff rank will be assigned to the RAPs. So, areas that would convey half the surface runoff from the watershed that flows through the RAPs to the stream, considering if all areas were to generate runoff equally, would receive a rank of high. RAPs where a buffer occupying exactly 2% of the total contributing area to the RAP would be wider than 10 meters receive a rank of medium. And a 10 meter wide or narrower buffer that provides a minimum recommended buffer area ratio of that 0.02 or 2% receives a rank of low. So that 2% buffer area ratio is what's generally needed, and this is recommended by NRCS. The buffer area ratio is calculated by taking 2,500 divided by the contributing area along those bank cells within a RAP. That 2,500 is equivalent to the area of a 10 meter wide buffer along that 250 meter long RAP. And so basically you can see down here that if that buffer area ratio is less than 2%, median runoff rank is assigned, and if it's greater than 2%, a low runoff rank is assigned. Alright, so depending on those ranks and the cross-classification of them, the ACPF will make a riparian function recommendation. So if both received a high rank for the runoff and denitrification ranking, we consider that a critical zone. Attention needs to be paid to that riparian area. If the runoff rank was high or medium and the denitrification rank was also medium or high, then a multi-species buffer is suggested, and this will just help with water uptake and also nutrient and sediment trapping. If the runoff rank was low, but the denitrification rank was high or medium, then a deep-rooted vegetative buffer, and you want to make sure that this vegetation type is tolerant to saturated soils. If the runoff rank was high or medium, but the denitrification rank was low, then a stiff-stemmed grass buffer, which will trap and slow runoff and sediment to the stream, that will be recommended. And if both were ranked as low, then we still recommend stream bank stabilization. It is important to have happy and healthy banks. Alright, so our tool is finished running. We can see our riparian function table has been added to our map document. So So let's just open it up real quick and take a look. So we can see we have a wrap ID field, which means we can join it to our wrap polygon. And we will in a minute do some symbolization. But we'll just take a look at some of our fields real quick. So we can see that we have the width of a very low-lying area. This is that less than 1.5 meters above the stream channel. We have the width of still low-lying area of 1.5 to 3 meters above. The width of 3 to 5 meters above. Then we have our buffer area ratio right here. We have the runoff rank and the denitrifying potential rank, which were used to classify our riparian function. So we can see all the different classes right here. Then we also have the NRCS recommended buffer width and then the ACPF recommended buffer width. So let's do some symbolization. We'll go over to our wrap feature class, do join, and we're going to join our riparian function table, joined by the wrap ID, and we'll hit OK. Then let's go into symbology, go down to categories, and I'm going to choose to symbolize it by the wrap function. I'll hit add all values, just do some quick coloring. I'm choosing things that make sense to me. Obviously you can choose to color this any way that you see fit. So I'll just make this a nice green. And then stable bank. Let's go to muddy brown, hit apply, and OK. I'm going to turn off my hide above channel just so we can see it clearly. Alright, so we see we have a variety of results. I only have one critical zone, at least one zone that was classified as that. So that's pretty good. And then just this gives you an idea of what sort of riparian functions could be used along these banks to improve your overall riparian corridor health. Here's a brief recap on the Riparian Function Assessment tool.